Hello and welcome again to the FE Mechanical Preparation Exam, Chapter Electricity Practice Exam number 12. The problem states the following. What is the magnitude of the force on charge 2 due to charge 1? And there is a separation between the two charges, and they gave us Q1 3 microcoulombs, Q2 10 microcoulombs, and they gave us the Coulomb constant. So the first things I'm going to bring the formulas and equations that they are given in the handbook. The force related to these two charges are related to this formula that it's underneath is F2 equals Q1, Q2 divided by 4 pi permittivity divided also by the distance, square the distance. And R12 is a vector, so we are not going to take into account because they ask only for the magnitude. So we know that because they are negative, one is negative and the other charge is positive, they are going to attract each other. If they were the two similar magnitude, they are the similar sign, they are going to the force are going to go to the other side. So this is the force, and this is another force that they are exactly the same. So the equation we are going to put F without putting 1 due to 2 or 2 due to 1. We are going to have Q1 times Q2 divided 4 pi permittivity R square distance. So the only problem here that they give us a Coulomb constant that is not, unfortunately, is not in the FE handbook. So you need to know the formula in some way that is this one, that is very, very similar. So kappa, that is the Coulomb constant, it's times Q1, Q2 divided the square of the distance. So we have, this is a much more easier formula. So we have the Coulomb constant, we have Q1, Q2, and the distance. So if you remember this, it's easy to remember because you can relate one formula that is in the handbook versus the other formula that is not in the handbook, but it's easy to remember. So if we put the numbers there in the equation, so the Coulomb constant is 9 times 10 to the power of 9 Newton times square meters divided by Coulomb, square Coulomb. And then Q1 is 3 microcoulombs. Q2 is 10 microcoulombs divided by the distance, square the distance, that is 0.15. Let's put like this, square and square meter. So now we are going to have a couple of things because this is microcoulombs. So microcoulombs and microcoulombs is basically 1 coulomb is 1 to the power of 6 microcoulombs. And because there are 2, square that. So, and then we are going to see what can we do with this, the units. So square meters, it's cancelled with the square meters. And then we have microcoulombs and microcoulombs in here. So they are going to cancel in here. And then the coulomb is going to cancel in here. So the full is going to